Hello and welcome to another video tutorial on how to use C++. So far we've been structuring our code functionally. So we've used command blocks, control structures, or functions. But because our source code is getting bigger and bigger, I'm going to show you today how to split it into different files and structure it with regards to content. We create a new project, name it number 7 header, then as usual next, empty project, and then we add a new source data, new element. For now still a C++ file, but later I'm going to show you how to use header files. So this time still a main.cpp, and then our standard structure is to include the I/O stream, then include the string library, create the main function, which includes a return value. You might have noticed that I didn't include the standard namespace. This is because there's no need for that in header files. But to complete the code so far, we add two small functions. The first one has a string as an output, and it goes like this. So because it doesn't have a return value, it's a void, and the name of it is echo. We assign a string to it, so string str, and now you see that it claims string is not defined. That's why we have to add the namespace std in front of it with the scope operator, the double colon. And this function should just have an output. So the only command here is from standard namespace, scope operator cout, and the output should be the string. And then end line. To test this, we can define a string down here. So again, standard namespace, scope operator, string, just a text, and this text should be hello world. And then of course we have to put this into the output, so the function echo of text. We can run this to see if it works, and you see the output is hello world. And the second function should check if a value equals 0. To do that, we need a definition at the beginning which says define use math defines. And what this does is we have access to mathematical constants with it. So we can add this at a comment here, mathematical constants, and I'm going to tell you later why we need it. And while we now already have mathematical constants, we can also have mathematical functions. So we include cmath and just add the comment that this is mathematical functions. These functions include some like sine or cosine or norms, and we want to use these functions and constants in our second self-created function, which should check if a value is 0. And for that we have the return value bool, because it's just a yes or no. Then we use the name is 0, and we assign a double to it. Then our variable is called is0, and is0 uses one of our functions. This one is the absolute value from a number. So abs, here you can see that it is from math.h. And so it calculates the absolute value from the double x. And if this absolute value is smaller than dBl underscore epsilon, this is just a threshold of 2.2 times 10 to the power of minus 16, which is the smallest representable number. And it is defined that epsilon plus 1 is roundabout 1. So we use this. Then the end of the function is we have to return our is0, which is then just true or false depending on whether the absolute value of our x is smaller than epsilon, which means then that it is 0. So let's test this in our main function. We have to define a double for this named d, and here we can use our mathematical functions again. So we use sine of pi, which is a mathematical constant, and because sine of pi is 0, we can now check if d is 0, which should be. So we just write an if condition. If is0 function of d, then the output should be, and here we use our first function again, echo, and then the output is d is practically 0. Then execute the program, and then we can see here that the first output is the hello world from our first function echo text. Then the second output is d is practically 0, which confirms that sine of pi is 0. You can see that we wrote this amount of code quite quickly, and I told you that I want to show you how to split the code to structure it, and this is done with header files. You can recognize those by their ending .h, and you can also embed these by using include in the beginning. But before we do that, we have to create one. So we go to header files and add a new element. Then this time we choose .h and not .cpp. So .h, and we name this function .h. So add, and then you can see it has been opened into a new tab. On the right, this is our main CPP, and on the left, this is our new header file. And what's in here is just that in the header we have our function declarations. So just put a comment here, function declaration. Okay, let's take a look back to our main function, or better is our list here over the functions. And what we put into our header file is just the declarations of our functions. So the first line, the header of it, not the body. So we can just cut this line or copy it and put it into the header function. Don't forget the semicolon. We can do the same thing with our is0 function, so copy it and paste it into the header file. Save. But so far, these functions are not stored appropriately because we only have the function header. We have no information about what the function is actually doing, so that's why we need a new element here. And this time we choose a CPP file and name it the exact way the header is named. So function.cpp, and add this. So now we can cut this whole section and paste it into our CPP function CPP file right here. So save, and what we have in this function.cpp is our function definitions. So I'm just gonna add a comment here for these are the function definitions. And because we access functions from different libraries, we also have to include those. So in the beginning, as usual, we add include IOStream and include string. So now we stored our functions in other files and not in our main CPP. But still we cannot access these functions because our main cannot access the header file. So if we try to run this, you can see there's a lot of errors that occur because these functions are unknown. So we have to embed the header file, and this is done just as the libraries with the include command. So we type in include, and this time, because it is a self-created header file, we don't need these angle brackets like before. Instead, we use quotation marks. And you can see that the auto-completion already suggests the functions.h. And now with this line, this should work. And you see it's successful. So by adding this line, the compiler now knows that it has to use the whole code from our header file. So the text from there is just virtually added to the main functions, and we can use all of our created functions. So this is on how to structure our code by content, and thank you for your attention.